Multi-touch input is both immediate and intuitive, providing rich interaction from multiple points of contact. However, the interaction is limited by the two-dimensional nature of the input, particularly when working with three-dimensional content. To move beyond this limitation, we introduce the concept of anchored multi-touch gestures, where the posture of the hand is tracked above the surface. These gestures are distinct from previous work in freehand above the surface interaction, in that the gesture is performed while maintaining an anchoring touch contact with the surface. This allows users to move fluidly from traditional multi-touch interaction to anchored above the surface gestures, gives haptic feedback, and helps improve stability and control of precise movements above the surface. In our paper, we define a taxonomy of anchored multi-touch gestures to explore the design space, and two application case studies, anchored 3D modeling and 3D navigation. For 3D modeling, we define two gestures to perform elementary bend and twist deformations. Pivoting around an anchored finger and thumb on one hand changes the angle of the bend, while a second hand controls the amount of curvature. The twist gesture allows users to simultaneously adjust the rotation of the top and bottom of a surface, curling it around itself. A low-cost depth-sensing camera is used to capture the spatial input above the surface. This technique allows quick, almost sculptural interaction. Our second case study uses anchored gestures to navigate a 3D airflow dataset. A bimanual pivot gesture rolls the visualization into the surface of the display. A similar gesture, where the fingers move in opposite directions, translates the visualization into and out of the surface of the display. Using these anchored gestures, users are able to move beyond the traditional multi-touch surface to interact with 3D content in a more expressive and intuitive way.